Hello everyone, thank you for joining us for today's webinar, Scheduler Optimization Tool. If you happen to experience any technical issues during the presentation today, please use the raise hand button on the upper left hand corner of your screen and we'll attempt to assist you. We will allocate time after the presentation for a question and answer session, so if you have any questions throughout the presentation, please enter these into the chat box on your screen and we'll do our best to address these later. Now to introduce our presenter for today, Lawrence Chikonde. Lawrence is a senior mining consultant with CAE Mining in Perth. A mining engineer graduate from the University of Zambia, Lawrence has over 7 years experience in underground mining operations and planning and has had 5 years experience in production and planning for block cave and sub-level caving mining methods. He has worked on underground projects in South America, Africa, Asia and Australia, and his most recent projects include a short and medium-term planning and training project in India and a strategic and life of mine planning project in Brazil. Thanks very much, Lawrence.
Thanks, Eloise, and welcome to the SOT webinar, everyone. I'll just be sharing my screen shortly. Can you all see my screen?
Yes, we can. Thanks, Lawrence.
All right, excellent. Okay, so welcome to the CAE Mining SOT webinar for April 2014. I'll start by taking you through the webinar content. We'll start by looking at what SOT is, what SOT can do, the benefits of using SOT, where SOT fits in terms of mine planning, how SOT works, the data inputs, outputs, and then finally we're going to have a demo. So what is SOT and what does SOT do? SOT stands for Scheduler Optimization Tool, and SOT is a software that automates the scheduling of mining activities and optimizes the net present value of your project based on a financial model, as well as constraints such as sequencing, resources, availability, efficiencies, and those sort of parameters. SOT also gives you the leverage of varying your financial model or creating various financial models as well as constraints and applying different combinations of your financial model and constraints to come up with various schedules. And then you would select the schedule that best suits your what you're looking for in terms of net present value as well as scheduling of mining activities. Next, the benefits of using SOT. So the first major benefit of using SOT is in terms of the time saving from what you get due to SOT scheduling efficiency. So if you were to create schedules manually, that would mean you'd have to create a sequence, export that into your financial model, and then come up with the NPV. And then if you want to change a few things, like focus more on your higher grade material, then you get back into your schedule, create more different dependencies, send that back into your financial model, and come up with the NPV. And if you have to do that 10, 15, or 20 times, then you take a lot of time just to look at what sort of scenario would give you the best NPV as well as the mining sequence that you're looking for. So in this case, SOT does all that for you. It will create thousands of schedules within a short period of time. And then you can just nominate to look at maybe the top 20 or top 15 schedules, and then look at which schedule actually gives you the mining sequence that you're happy with, as well as an excellent NPV. The next is in terms of project value improvement. So with the ability to choose from numerous schedules, picking on a schedule that gives you a good mining sequence as well as a great NPV means you increase the value of your project. Then you can have numerous competing scenarios where you set up different financial models, different constraints, and look at different scenarios that you can employ, and then strategically pick up one scenario that suits you. A good example is you can have a financial model that looks at different economic environments. So an environment where the metal prices excellent, the really good, what sort of strategy should you employ, what sort of schedule can you use, and then in an economic environment where your metal prices are not so good, then you carry out different scenarios and see what sort of schedule should you create, how many resources and equipment should you have. The other benefit that you get from SOT is the fact that once you have created your schedules from SOT, you can seamlessly move these schedules into EPS, resynchronize them with Studio 5D Planner. Then you can look at how the activities are sequenced from the visualizer in Studio 5D Planner as well as the visualizer in EPS InTouch. So that's a seamless process, and just a few steps to be able to see all of that. Some of the other benefits include cost saving. One key thing is SORT will immediately help you look at the bottlenecks in your project. Then once you identify your bottlenecks in your project, it will give you the leverage of optimizing a production rate. So you look at a production rate and say, okay, fine, if I change the production rate for these resources, how is that affecting my schedule? What sort of life of mine am I getting? What's the NPV that's coming out of that? Then you also have the opportunity of identifying and reconciling unit costs, as well as picking different strategies that you'd use in different economic environments, as I had alluded to earlier. Then you have the ability, to look at how you can minimize the risks in obtainment for your plan. So once you create a plan, you want to look at what are the risks involved in us actually actualizing this plan and realizing it. So on the screen right now is a slide that is showing 3 different scenarios. The first one is SORT creates a schedule based where it's guided by material of low cost. So it's prioritizing material that has low cost or mining activities with low cost and bringing them as early as possible in the schedule. In the second one, it's focusing more on the material with high mineral weight. And on the third one, it's looking at material that has a high grade. And in the graph below on the bottom right, the first graph shows us the high mineral grade NPV. So the white represents the maximum NPV, the yellow is average, and the blue is minimum NPV. So you would see that on the high grade schedule, you have an NPV that's around 115 million. The high mineral weight schedule gives us an NPV of slightly below that. And then we have the low cost schedule, which gives us an NPV of over 120 million. And then if you look on the right-hand side, on the left-hand side, you realize that the high-grade schedule actually has a higher risk of obtainment because there isn't so much material with a higher grade, meaning that if for some reason we are not able to mine out that material with a higher grade, maybe a geotech reason, then the probability of us obtaining that NPV or obtaining our plan reduces, and therefore that plan has a higher risk. Whereas on the other hand, the high mineral rates and low cost schedules have more activities that can be mined, and therefore for one reason or the other, if you're not able to mine some of the activities, you still stand a good chance of actually obtaining your plan. SORT is also a tool that lends itself well when it comes to strategic planning. In this slide is an example where we're looking at what sort of strategic decisions you'll be faced with and how SORT can actually help you in making those decisions. So the first instance, we have a schedule with the highest NPV of about 350 million. And in this schedule, there is no shafts, but we're just running on declines. In the second schedule, we use a shaft, and the expense for the shaft is about 105 million, and the NPV grows to over 350 million. In the last instance, we have a shaft which is at 105 million, and the NPV drops below 350 million. The average NPV also takes the same sort of format. So from this perspective, you can see that the best option here is actually to sink a shaft at 105 million, and that would give us more value for our project. So NPV with SOT, we can actually carry out numerous scenarios such as these, just to look at what sort of strategic decisions you'd make that would ultimately give your project a higher value in terms of the net present value. So where does SOT fit in terms of the mine planning process? So this slide is showing us briefly the mine planning process. The first part is the strategic mine design, where you would use a mineable shape optimizer, MSO version 1.1, or you would use MSO version 2, which is now called UGSO, soon to be available on the cloud on our Summit platform. If you want to know more about MSO version 2.4, we had a webinar earlier this year. You can just go onto our website and just look through it. It's really an exciting package, a lot of really good stuff in it. So once you've done your strategic mine design with SOT, with MSO, that output, that is the stock designs, are easily inputted in Studio 5D Planner. It's a seamless process. And with Studio 5D Planner and EPS, you come up with your scheduling and mining sequencing. Then you can export your long-term, medium-term, or short-term schedule from EPS into SOT, where you carry out your automated activity scheduling, as well as optimization of the NPV based on the financial models that you will define. Next, we look at how SOT works. So SOT uses heuristics and evolutionary algorithms in creating schedules and evaluating the schedules based on your financial model, as well as the constraints that you will have defined, which we talked about earlier, resources and parameters such as those. I will not get into the details of heuristics and evolutionary algorithms. There's a lot of information about this online, so you can just get on the internet and get lots of information about that. Next, we're going to look at data inputs that you would require to use SOT. So as alluded to on the previous slide, data that is used in SOT will come from EPS, and all you need is the EXF file from EPS. The key fields that you need to import into SOT are 5 fields. The first one being the weight attribute, which is required for scheduling. The second one is the measure of length. That can be 0 and must exist for all of the tasks. And the third one is the mineral, the driving mineral grade, which can also be 0 but must exist for all tasks, and this is the actual mineral that's being mined out. Third one is mine area. All activities in SOT need to have a mine area that they belong to. So it could be in your mine, you might have two limbs or lenses, or you might have the ore body divided into different mine areas. So that is where you add that sort of information. The last field that is really important to add is the activity type, so that you can define your activities in terms of capital development, operational development, production drilling, and those sort of definitions. You can also add whatever fields that you feel you would need to use in SOT as text fields, and you would have them available to use in SOT. So once you have imported those 5 fields, the next thing that you need to do is to define your constraints. So that would be defining your resources, defining your resource capacities. Then you would move on to defining the relationships between your resources and the activities that you have imported in SOT. Then finally, you define your financial scenarios, your mining scenarios, and then you're good to go. You're good to run SOT. Once you run SOT, then you'll be able to get the results. On the screen right now is a screenshot of how results in SOT would look like. So if you look under this run section, I have about 7 runs that I ran in SRT, and for each run, sort gives me the maximum NPV that was attained in that particular run. I'll take you to this last run, which is run P1.11. So that shows you that we had 100 iterations, more of 100 runs, 100 iterations, and I requested Sort to give me the top 5 schedules from those 100 runs. And you can see the top 5 schedules based on NPV. The first schedule, the top schedule, was created on the 76th run, on the 76th iteration. And the second one is on the 83rd iteration, which just shows you if you had to do this process manually, you would have to do it 76 times in order for you to, following the same sort of route that SOT takes in order for you to come up with that NPV of 145 million, which is really time consuming. So once you get this sort of result, you also get statistics on your run, you get statistics on individual schedules. This is just an example of the sort of statistics you get on the entire run. So that shows like 570 runs, the average NPV, maximum and minimum NPV, as well as individual information about each specific run, in this case referred to as a reset in a run. So you have the different generations and the NPVs that were provided. So with all that scheduling information out, you can export that information into Excel, where you can analyze each schedule and look at what sort of production results it's giving you per panel, per level, and mine area. So you just create a template where you just load this data in Excel, and then you can quickly make a comparison in between your different schedules to see which one is probably the schedule that you most prefer, despite knowing the NPV value. So the results can also be exported seamlessly back into EPS, where you could resynchronize the data with Studio 5D Planner. Then you can look at the animations in terms of the sort of automated sequence that Sort's giving you. You can look at that in the VR window in 5D Planner. And you can also look at that in EPS InTouch. If you need to make any further changes to your design, you can make changes to the design. You can add more refinement in EPS and send the data back into Sort. And within a short period of time, as you'll be able to see when we get to the demo, you'll be able to get a schedule of SOT out. So that is the end of the first part of our webinar, where we're looking at the presentation. Next, we're going to look at the demo for SOT. So we'll just quickly just close that up, take you through how SOT looks like. Okay, so on the screen right now is Sort. It's already opened up, so I've already set up the project. So the first part just shows us the activity, and while creating a project, there's no more create new project, then you can import activities from there. Very simple, quick step. Then you can look at your imported data. So I have the fields that I've imported down there and the field type. Then I have my text fields over there. Then here I have the total number of records that I've brought in. The next part shows you the minerals that you have imported. So I have imported in gold. It's the only mineral that I'm running with. Then these are the activities that I've imported. So I have rockfill, operation development waste, I have operation development ore, I have capital development, and I also have vertical development. So these are the activities that I imported. So the first thing that I do is define my resources, and I've already defined those resources, and it's very simple to do that. All you do is just double click there and say I want to have a drill rig, and then you have the drill rig. And then you just define the unit, meter, and that's about it. So I have already done that just to make the demo a bit faster. So I've defined those resources, that's my equipment. The next thing is to define my capacity profile. So in my capacity profile, I'm just saying what sort of capacities, what sort of rates are my equipment running at. So I created one capacity profile for the jumbo. So I have this capacity profile with varying capacities across the years. So I'm saying the first 10 years, my capacity is 7,200. In the next 15 years, after 10, it's 7,000. And in the rest of the life of mine, it goes down to 6,800. So I can define different capacity profiles for my jumbo that I can then apply in sorts. And I have the other capacity profiles that I've defined for my production boga, which also varies over the years, as well as production drilling, which is just the same over the years at 120,000. So once I have, at this point, I've defined my resources. Next is I define my capacity profiles for those resources. The next thing is to bring together the resources, the capacity profile, as well as the activities that I had imported initially in EPS, from EPS. So I do that using the resource pool, where I bring in, I say that this jumbo that I defined in my resources is linked to this capacity profile 1, and that capacity profile 1 is linked to operational development waste and capital development waste. So that happens in the resource pool where those relationships are established. You can also set up account capacities, which is a limiter for the number of times a specific activity can take place in a mine. For instance, if you want to limit the number of blasting activities to take place only twice in a day, then you say blasting can only take place twice in a day. It should not take place more than 2 times or more than once or more than 3 times in a day. Once that's set up, next thing is setting up our financials. First thing is setting up a cost code table. So I've set up a cost code table based on a text field that I had in EPS. So this text field just tells me the relationships in between these codes and the activity types. So code 1 represents capital development, and code 2 represents operation development. And all I do here is insert the cost for capital development, insert the cost for operation development, and all the other costs, and then set up the units for those specific costs. Once I set up my cost code table, next I set up my price profile. This is really important, especially when you're dealing with polymetallic deposits, where you set up different price profiles for gold, and if you have silver, then a price profile for silver. And this is how a price profile looks like for gold. So I'm saying that for gold in the first 6 years, the price is about 1,200. And then in the next 15 years, it's going to be 1,150. So those are just arbitrary figures. And then next, after the end of the life of mine, after those 15 years, it's going to be 1,100. So you can do that for other commodities if you have a polymetallic deposit. But even where I have just one commodity in my deposit, I can also set up different price profiles for gold. So I could say, how about if the price for gold actually changes? In the first 6 years, if it's below 1,000, it's 1,100. So you can set up that sort of a profile and run sort on that, so that sort gives you a schedule based on that sort of a price. The last part is setting up my, under financials, is setting up my financial scenario, where I set up my discounted, annual discounted rates, my inflation, and then finally I just link my mineral price profile to the commodity that I'm mining out. So I'm just saying that this gold mineral price profile I'm creating a relationship between the gold mineral price profile and the gold activity that I imported from EPS. Then I'll set up these sort of relationships for other commodities. If I have a polymetallic deposit, I'll set up similar relationship for silver, for copper, for cobalt, etc., etc. Once the financials are set up, the next thing is tying all that together with this activity types table. So the activity types table just brings together the activities based on the activity code. So I say activity 1 is capital development, activity 2 is operation development, activity 3 is operation development waste, and then I link that with my cost code table, and all I do is go down to the drop down menu because I've already created my cost code table, and it immediately brings the cost over there. Then I just set up this field called the objective field, where a false represents an activity which does not give us value, and the true activity is an activity that gives us value. So in this case, wherever I have all, then I have to say it's a true activity, and sort will be able to prioritize that activity to make sure that it goes for its first. Then I assign my resources for each particular activity. Once that's all set up, and all of this stuff is easy to do, you can also, if you have these sort of tables already created in Excel or anywhere else, you can just copy and paste them. You can also, if you already have an existing sort project, you can save these profiles and then load them in other projects as well. You also have the leverage of saving the entire project. If you just come to export configuration, then you can save the entire project. When you create a new project, you can just import the project settings from that old project, and then you have all of this stuff set up for you. All you have to do is just make a few changes and tweaks. So once I've set up my activity types table, next thing is setting up my mining scenario, where I'm saying what sort of different scenarios am I going to have. And the reason why I'm setting up this mining scenario is I can have different financial scenarios. In this case, I only have one. I can also have different resource pools where I have different combination of resource rates. So under the mining scenario is where I bring everything together. I would say, okay, for mining scenario 1, I'll use resource pool 1, I use financial scenario 1, and I'll use the activity types table 1. So if I have set up another resource pool in financial scenario, then I can set up a different mining scenario for those. Then I can also set up my recoveries, which can be set up in a bit more detail. So if you have mill recovery, and if you also want to set up mining recovery, then you can set that up as well and say mining recovery is at 90%, and then sort will work out the average of those two and use that as the recovery. Once your mining scenario is set up, you can choose a scheduling period, and you can have as many as possible, just number of weeks. It could be a yearly, it could be a weekly, daily, and you have the options of choosing minutes, hours, days, and weeks. Then finally, we get to the interesting part of sorts, where you set up your run. I know I've kind of like gone through a lot of stuff that you need to set up, so I'll just briefly summarize that. First thing I did, or you have to do, is to import your activities, which have to be 5 fields, important 5 fields. Then you set up your resources. Then you set up your capacity profile, where you're just setting up the resource rates. You set up the resource pools, where you bring up your activity, resources, and resource rates together. Then you set up your financials. Then you set up your activity type, mining scenario, and now we are setting up the run configuration in terms of how sort is going to run for each specific run. So in this case, I have a run P1, and it's using mine scenario 1. and I can change the start date, but it's using the start date that I have on the schedule from EPS. Then I get to choose the optimization method, where it gets pretty interesting. So in this case, I have this test run. So a test run, quickly runs through your data and follows the constraints that you've set up and the financial scenarios to come up with the schedule. It's a quick run, but it still gives really good results. So from the test run, you can also have a learning run, where you get a test run and use that. If you find a test run that you're happy with the mining sequence and the NPV looks pretty good, you can use that run and create it as a seed that should feed into the learning run, and then Sort will be able to carry out a detailed run that would give you a better NPV and a better mining sequence. Then you have guidance, where you can choose what sort of guidance do you want to give Sort while it does the run. So you can tell Sort to focus more on areas in your mine that have highest mineral grade, or you could just follow activities with highest mineral grade, or you can have it follow activities that have a higher mineral grade in a particular area, or basically highest mineral weight, where you have the highest quantity of material, or activities with the highest material quantity. You can also have Sort look at areas with low cost, so it prioritizes areas with low cost, or you can follow a rank. If in EPS you have created priorities in terms of how activities should be mined out, then you can use a rank to represent that priority, which is a field also imported in Sort. Then here is where you set up the percentage guidance, and if you don't want to have any guidance, then you can just say 0 guidance. Here you set up the percentage guidance, where you want it to be 0% guided, 85 or 35% guided. In this case, I have two scenarios where the scenarios are exactly the same, but I just vary the guidance. One of them is 35% guided, the other one is 85% guided. And once these two schedules come out, I will compare them and see what sort of effect the guidance is having on my schedule. Is lower guidance giving me a better NPV and automated mining sequence, or is higher guidance actually giving me that sort of result, a better result for my data type? And then from there, I'll be able to refine it better. My scheduling period is a quarter. Here is the number of iterations that Sort will be able to make for this run. So run P1, which is the run name there. Run P1 is going to have 100 iterations, meaning that it's going to start and finish 100 times, and then it's going to produce lots and lots of schedules. And then I'm saying I only want to look at the top 5 resets for each iteration. So for each iteration, Sort produces a lot of schedules, and I only want to look at the top 5 iterations, and then from each iteration, I just want to look at 2 schedules, the top 2 schedules. So one iteration gives me a lot of schedules, and from that iteration, I want the top 2 schedules, and I'm going to look at 5 iterations. So that gives me the top 10 schedules to look at. Then there is this sliding button that just allows you to look at, to set whether you want Sort to focus more on the activities that give you value, which is the stopes, and then just run your development activity just in time to mine out the stopes. So once you carry out those runs, and I will actually just fire up one run, which is the last one. It has it's going to have 3 iterations, and it's going to give me the top 3 schedules. And I'm going to have a total of 6 schedules coming out of those runs. And it's really fast, so I'm just doing this just to show you how quickly Sort runs. So that's run P1.6 test, it's up and running down there, and it's already run, and I have my results down here. Run 1.620, and you can see how so I'd already run the rest of these other runs. So you can see how sort lays out the data. It gives you the run with the highest NPV first, and the rest of the other runs with lower NPVs follow. So if I look at run 1.1, gives me just the stats on that run where I have maximum, minimum NPV. Then I can look into further details in terms of the mining scenarios or the other configurations that I've put across. And I can look at the schedules. So I have the top 5 schedules down there, and I can look at information from a specific schedule, and I can export these schedules to EXF, or I can export them to CSV, or I can just create a report in CXV where I can look at the information in Excel. So this is ideally how SORT runs, and roughly how you can be able to look at the results from SORT, export them into, as we were looking in this particular slide, export them into Excel, come up with graphs and look at how that data looks like, and make a choice on which schedule you would like to run with, or export the data back into EPS, run your animations in EPS, and then make any further changes and then run them back into SORT. So that brings us to the end of our SOT webinar for April 2014. I'll hand you back to our chairperson, Eloise.
Thank you very much for that, Lawrence. It is now time for our question and answer session. So if you haven't yet flagged a question in the chat box, please feel free to do so. So the first question that we have here for Lawrence is, does SOT have a visualizer?
All right, so SOT does not have a visualizer, but as you were able to see, it seamlessly links to EPS, and then from that you can be able to use Studio 5D Planner VR window or EPS in Touch VR window for the visualization. Thanks.
Thanks, Lawrence. Another question we have here, how easy is it to allow for the fixed and variable component of a jumbo development production unit underutilizing a second spare jumbo?
Sorry, could you come again with that question?
Sure. How easy is it to allow for the fixed and variable component of a jumbo development production unit underutilizing a second spare jumbo?
All right. So ideally, I'll just go back to SOT and show you where I have my jumbo. So I have my jumbo there. I just define my jumbo just as one resource, jumbo. And then when I come and create my jumbo capacity profile, that's where I set up the rate at which that jumbo would run. So in this case, this rate is not just for one jumbo, but it's for actually 3 jumbos. So I know I have 3 jumbos, I'm going to run them there. So the idea is all of the jumbos are running at the same rate, and then SORT is really going to, basically apply them for different activities at more or less the same time. So if you want to have different rates, then you have to create a different capacity profile for the jumbo. But you also have extended settings that you can use for optimization. So there is what is called capacity flexing. So with capacity flexing, you can actually set the capacity to vary for a specific resource. So if I say, for instance, for the first 10 years, the capacity is 7,200, then I could say, can you vary that in steps of 200 going upwards, 4 steps? So it will move from 7,200 to 7,600, then 7,800, and ultimately 8,000, and going down the same way. And then sort will be able to use those variable capacities in that EA to actually carry out the optimization. I hope that answers the question. Next question, please.
Thank you, Lawrence. The next question that we have here is, how would you control the number of times a particular activity occurs in a shift or day?
All right, so that would be using the count capacity. So if I have an activity that I only want to take place, say 3 times in a day, then I have to create the name of the activity. I'd spoken about blasting earlier, so I'd say maybe blasting, or I'd say development, and then so that should, in a day, for a specific activity number 1, that activity should take place just once a day. And then sort will be able to make sure that this activity just takes place once in a day, and it doesn't take place more than that number of times. So if you want to take place 2 times in a day, and then you just do it like that. Next question, please.
Thanks, Lawrence. The next question is it possible to give sort a date after which to start scheduling an optimization?
Yes, so you can actually do that. Give sort days when it can start carrying out optimization. And you can do a bit more than that. You can actually, if you have activities that you want to start at a particular date, you can actually create a timestamp where you say this activity should take place at this date and the other date. And that can be done in EPS. So you create a field in EPS where you have activities taking place at specific times. When you import that field into sort will use it as a pin marker and will ensure that activities start at those specified dates. Next question, please. Next question, please.
Sorry, Lawrence, we might have to wrap it up there. Just we're out of time. So this does mark the end of the webinar. Thank you all very much for attending. We hope that you found the content presented valuable. If you did submit a question that we were unable to address, please rest assured that these have been recorded, so we'll touch base with you afterwards to follow up. You'll now be redirected to an online feedback form. It will take no more than a few minutes to complete, so if you have the chance, we'd really appreciate your feedback on how today's webinar went. We will also be sending out follow-up emails to all of our attendees. This email will provide you with a recording of the webinar as well as the necessary details to contact us should you have any additional queries. We look forward to hearing from you soon. Thank you all once again for attending today's webinar, and thanks very much, Lawrence.
Thank you, and thank you everyone for attending. Bye-bye.